Exhaustive cases, which mean the total number of possible outcomes in a random experiment, is called as exhaustive cases. In other words, the total number of elements in the sample space is known as number of exhaustive cases. Example: if we toss a coin, then the number of exhaustive cases is 2 and the sample space in this case is head and tail. Example 2: if we throw a die, then the number of exhaustive cases is 6 and the sample space in this case is 1, 2, 3, 4, 5, 6. Favorable cases. The cases which favor to the happening of an event are called as favorable cases. Example: for the event of drawing a cord of spade from a pack of 22 cards where the number of favorable cases is 13. Example 2. For the event of getting an even number in throwing a die, the number of favorable cases is 3 and the event in this case is 2, 4, 6. Mutually exclusive cases. Cases are said to be mutually exclusive if the happening of any one of them prevents the happening of all others in a single experiment. For example, in a coin tossing experiment, head and tail are mutually exclusive as there cannot be simultaneously occurrence of both head and tail. Equally likely cases. Cases are said to be equally likely if we do not have any reason to expect one in preference to other. If there is some reason to expect one in preference to other, then the cases will not be equally likely. For example, head and tail are equally likely in an experiment of tossing. This is because if someone is expecting, say, head, he or she does not have any reason as to why he or she is expecting it. You will become more familiar with the concept of equally likely cases from the following example, where the non-equally likely cases can be taken into considerations. Cases of passing and not passing a candidate in a test are not equally likely. This is because a candidate can have some reason to expect passing or not passing the test. If he or she prepares well for the test, he or she will pass the test. If he or she doesn't prepare for the test, surely will not pass. So, here the cases are not equally likely. Example 2. Cases of falling a ceiling fan and not falling are not equally likely. This is because we have some reasons for not falling if the bolts and the other parts are in good condition. That's it about the concept. Subscribe to this channel, which is actually free of cost, or at least hit the like button so that it gets recommended to others. Thank you.